If you've ever looked at the SAT Math section and felt like algebra is everywhere, that's because it is. In this video, we will cover all of algebra on the SAT. By the end, you'll know exactly what to do when you see any algebra problem on the SAT. Let's get into it. Section 1. Linear equations. Solving one-variable equations. The most basic algebra question on the SAT gives you an equation with one variable and asks you to solve it. The goal is always the same: isolate the variable. Here's an example. 3, 2x plus 4 equals 30. Distribute the 3. Subtract 12 from both sides. 6, x equals 18. Divide by 6, x equals 3. The simplest question the SAT could ask you. Equations with no solution/infinite solutions. The SAT loves to throw in equations that don't behave normally. 4x plus 2 equals 4x plus 8. Distribute the left side. 4x plus 8 equals 4x plus 8. Subtract 4x from both sides and you get 8 equals 8. That's always true, so this has infinite solutions. When you see variables cancelling, don't panic. Just check what's left. Word problems to equation. This is where a lot of students lose points. Not because the algebra is hard, but because they rush to set up the equation. Read the problem, identify what you don't know, call it X, then translate the words into math. Example: a store sells notebooks for $3 each and pens for $1.50 each. Maria buys a total of 10 items and spends $24. How many notebooks did she buy? Let n equal notebooks and p equal pens. Two unknowns. Two equations. N plus p equals 10 and 3n plus 1.5p equals 24. From the first, p equals 10 minus n. Plug that in. 3n plus 1.5 times 10 minus n equals 24. Distribute and combine. 1.5, n equals 9, so n equals 6. Maria bought 6 notebooks. Slow down on setup. Once the equation is right, the rest is easy. Section 2. Linear functions. Slope and y-intercept. Interpretation on the SAT, functions usually show up in context, a real-world situation, and they ask you what the slope or y-intercept actually means. The formula is y equals mx plus b. You already know that, but the SAT doesn't ask you to graph it, they ask you to explain it. Example: the function c of t equals 40t plus 120 represents the total cost in dollars of renting a bike for t hours. What does 120 represent? The 120 is the y-intercept. It's what you pay when t equals 0 before riding a single hour. That's the flat upfront fee. The answer is 120 represents the initial rental fee. F of x notation. Some students freeze when they see f of x instead of y. Don't. F of x is just y with a label. F of 3 means plug in x equals 3 and find the output. Example: if f of x equals 5x minus 7, what is f of 4? Replace x with 4. 5 times 4 minus 7 equals 20 minus 7 equals 13. That's literally it. Word problems. Rate of change context. These problems describe a situation and ask you to build a function or interpret one. Example: a taxi charges a flat fee of $5 plus $2.50 per mile. Write a function that represents the total cost for m miles. How much does a 6-mile ride cost? Flat fee is your y-intercept. Per mile rate is your slope. C of m equals 2.50 m plus 5. For 6 miles, 2.50 times 6 plus 5 equals 15 plus 5 equals $20. Section 3. Graphing linear equations. Finding intercepts. Example: what are the x and y intercepts of 3x plus 6y equals 12? For the x-intercept, set y equals 0. 3x equals 12, x equals 4, so 4, 0. For the y-intercept, set x equals 0. 6y equals 12, y equals 2, so 0, 2. Parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. Flip it and negate it. Example, line A has equation y equals 2, x plus 5. Line B passes through, 0 minus 1, and is perpendicular to line A. What is the equation of line B? Line A has slope 2. The negative reciprocal of 2 is minus 1/2. That's line B's slope. It passes through, 0 minus 1, so the y-intercept is minus 1. Equation, y equals minus 1/2 x minus 1. Section 4, systems of linear equations. Substitution and elimination. A system of equations is just two equations, two unknowns. You have two methods. Substitution, solve one equation for a variable, plug it into the other. Elimination, add or subtract the equations to cancel a variable. Use substitution when one equation is already solved for a variable. Use elimination when the coefficients line up nicely. Example, substitution. Y equals 3x minus 1 and 2x plus y equals 9. The first equation is already solved for y. Plug it into the second. That's 5x minus 1 equals 9, so x equals 2. Plug back in, y equals 3 times 2 minus 1 equals 5. Elimination. 3x plus 2y equals 16 and x minus 2y equals 0. The 2y terms cancel when you add. 4x equals 16, x equals 4. Plug back in, 4 minus 2y equals 0, y equals 2. No solution / infinite solutions. Same idea as before, but now with two equations. If the lines are parallel, same slope, different intercepts, no solution. If the lines are identical, same slope, same intercept, infinite solutions. Example, kx plus 3, y equals 9 and 2, x plus y equals 3. For what value of k does this system have no solution? Rewrite both in slope-intercept form. For no solution, the slopes must match and intercepts must differ. So minus k over 3 equals minus 2, meaning k equals 6. Section 5. Linear inequalities. Solving and graphing single inequalities. Inequalities work like equations with one rule to remember. When you multiply or divide by a negative number, flip the sign. Example, minus 2x plus 5 is greater than 11. Subtract 5. Minus 2x is greater than 6. Divide by minus 2 and flip the sign. X is less than minus 3. Systems of inequalities. The SAT will show you a graph with two shaded regions and ask which system matches, or give you a system and ask which point is a solution. The solution region is where both shadings overlap. A point is a solution if it satisfies both inequalities when you plug it in. Example, is the point 2, 3 a solution to the system? Y greater than x plus 1 and y less than or equal to 3x minus 1. Check the first. Is 3 greater than 2 plus 1? That's 3 greater than 3, which is false. One failure means it's not a solution. You don't even need to check the second. Word problems. These usually involve constraints, a budget, a limit, a minimum. Example, you have at most $50 to spend on apples and oranges. Apples cost $2 each and oranges cost $3 each. Write an inequality that represents this situation. Can you buy 10 apples and 10 oranges? Your inequality is 2a plus 3o less than or equal to 50. Plug in 10 and 10. 2 times 10 plus 3 times 10 equals 20 plus 30 equals 50. That satisfies less than or equal to 50, so yes, just barely. That's all of SAT Algebra. Linear equations, functions, graphing, systems, inequalities. You've seen every type the SAT can throw at you. If this helped, subscribe. I've got videos breaking down every other section of SAT Math too. See you in the next one.